Hello, my name is Miroslaw and right now we will look into a short lecture introducing the concept of software metrics, in particular how software metrics are seen in the field of software engineering. The outline of this lecture will be that we will introduce the concept of software metric, we will look into the definition of it, we will look also into what kind of software metrics actually exist and what kind of software metrics are defined by the international standard ISO EEC 15939, which specifies, among other things, measurement information model. And we'll also look into the examples of different types of metrics in the end of the lecture. In the beginning, let's look at the definition of software metrics, how it is defined in software engineering. Software metric is a measure of some property of a piece of software or its specification. And here please note that the focus of that definition is that metric measures software specification, which means that it's the product that is being measured. On the other hand, there exists a whole mathematical theory behind measurements, which is called measurement theory, and there software metric is defined as a specific kind of function or relationship, which is called a homomorphism. Suffice to say that this homomorphism has a specific property. That property means that anything that we observe in the real world has to be observed in the mathematical world as well. So if you take as the example the last statement, that John is taller than Tom, mathematical definition of a metric means that if this is true in the real world, then when we perform measurements on John, of the height of John and Tom, then that measurement will give us this result, either true or false, which means that the height of John is defined as, or is measured as 1.96 meters. In the international standard, which defines what kind of software metrics actually exist in software engineering, which is a sub-definition of the general kind of software metrics, we can distinguish three types of software metrics. The base measurements, which are measurements like the height of person, very basic, that measure basic quantity, distinguished in software product. Then we have derived measures, which are combined of different kinds of base measures using measurement function. So there is a mathematical expression that is involved in that calculation. And then we have indicators. Those are special kinds of measurements, which are the main measurements used to monitor, control software projects, software organizations, or software products. The important thing about the indicator is that an indicator also has associated decision criteria. Those decision criteria help us to interpret if the indicator actually shows good status or poor status, which can be defined using the traffic light model. Another important aspect of the indicator is that every indicator, which is a specific kind of measurement, is defined for a specific purpose, for an information need, which is usually defined as a question which a stakeholder poses. We will now look into the examples of kind of questions that could occur in kind of metrics. But before we do that, let us look into the definitions of what a base measure, derived measure, and indicator is. So a base measure is a measure of, as I said, basic quantity, something that is independent from other measurements. And examples of that are lines of code of a program, McCabe complexity of the program, or the number of pages of a software documentation. A derived measure is a measure which is composed of two or more base measures, and the examples of those are, for instance, productivity or function points, very well known in software engineering. Whereas the indicator adds an extra level, as I said before, to software metric. It defines the analysis model. So as an example, the productivity can have a different criteria. We can have a good, acceptable productivity and non-acceptable productivity. And now let's look a bit more into the example of productivity. Let us assume that in our organization we would like to monitor if our development organization is productive. So we have to define the base measures, the number of lines of code produced by a designer, by the organization, and the number of person hours that is spent to produce those lines of code. The derived measure productivity is then defined as the ratio between lines of code produced and the number of hours spent on writing those lines of code. The indicator then defines 3 different levels. The acceptable level, when the productivity is between 5 and 20 lines of code per hour. Yellow, when the productivity is between 3 and 5 lines of code per hour. And unacceptable, when we can produce less than 3 lines of code per person hour in our organization. In one specific organization, we could have the following measurements, which is an instance of the productivity indicator defined in the previous slide. When we have lines of code produced by the organization, but that fictitious organization being 200 lines of code, produced by 50 designers, 50 people. Then our derived measures, the productivity is 4, 200 divided by 50. So then the indicator is yellow, because we remember that in the previous slide we defined the productivity to be yellow if it's between 3 and 5 lines of code per hour. And in this case it's 4. To sum it up, during this lecture we looked a bit into how software metrics are defined in software engineering, and we look into the types of metrics defined by the ISO standard, which is the international standard widely used in software engineering. We gave the definitions of an example indicator and associated measurements, and we looked how that indicator could be instantiated in a fictitious organization at a fictitious moment of time. Now, you have to answer the questions. Thank you.